Welcome back to our video series on the Play framework using Scala. We have finished our version 6 of our application. This one used Scala.js to modify the DOM. So we know how to use Scala.js in replacement of our JavaScript. We've also seen previously that for client side there are libraries like React that can make things much nicer. What if you want both? So what we're going to look at in this last set of videos is how we can use Scala.js and React at the same time. And we're going to start off doing this just in our standalone little project. In order to bring in React with Scala.js, the library that I'm going to use is called Slinky. Now there's a number of bindings, a number of what you might call facades that allow you to use React with Scala.js. I prefer Slinky. I think it has the closest feel to writing normal React code, and I find it to be rather highly productive. So this is what we're going to work with, and we're going to start off just adding a little bit of React into our standalone application that is only Scala.js. Now, I've added a few things that I want to show you. So first off, you do have to have the React libraries brought in on your website. So in our index.html, I added some lines for the React libraries. I also, in the build.sbt, I added 3 lines. 2 of these are including library dependencies for Slinky, Slinky Core and Slinky Web. Turns out that Slinky also supports doing React Native. So there is a Slinky Native as well that we're not using. In addition, I bring in the Scala Macro Paradise library, and that is because one of the elements that has been written for Slinky that makes your life easier as a developer is a macro. And so the Macro Paradise allows us to use a nicer syntax for doing our React. Okay, so let's go ahead and start doing this. We'll start off much the same way we did with when we first learned React. Let's go ahead and let's add another div here, and I'm going to give it an ID of React root. Okay, so nice self-identifying here. Everything that our React stuff is going to go inside of here. Now, of course, normally in a React application, this would be the only thing in the body, with the possible exception of some scripts or some hidden elements. But it would be the only visible element that you would put in there would be that React root, and that way React handles everything for the website. I'm leaving the rest of this code in here because it demonstrates how we're working with our Scala.js. And we still have this Scala.js code that was doing direct modification of the DOM. Now, in order to get this in here, we're going to do a call to React DOM.render, and you pass it a component and a target. Now the component are these React elements, and we saw when we did React, we used a create element call. We saw that there is this thing called JSX, which can be compiled into standard JavaScript, though we didn't go with that because of the extra tooling that it would bring in. In the case of Slinky, Slinky has this tag library that allows you to create things like a div, and if you import Slinky Web HTML, and I would normally import just an underscore so I have access to all of those, you can make a div here. There are also things like headers, and these are type safe. Okay, so instead of using the standard HTML syntax where you have your angle braces and H1 and then you close it off, you just say the name of the tag you want and then parentheses, and you give it a list of the arguments for what you want inside of there. We're just going to start with a simple hello Slinky, and then you have to tell it where you want it to go. Well, we do our get element by ID of that React root that we had put in here. And now this compiles happily. If we bring up our SBT, I actually had it running with the fast op. So theoretically, If we refresh this page, we get hello Slinky sitting there. Okay, so that was our most basic example. If you want to do anything interesting though, you don't just put in a simple tag, you put in a component. So how do we write components using Slinky? So I'm going to go ahead and I'm going to make a new file, and I'll just call it test component. And inside of here, this is where that macro paradise comes in. Use a macro called React, and then we're going to make our class for our test component and say it extends component, and we want the Slinky core component. And this will be unhappy because there's a few things that we need to include inside of here. So in JavaScript, the only thing that we had to do was the render method. And we will need to have a render method. I'm going to go ahead and make a div that has an h1 and an input. And as I did before, I'm going to change this import so it takes everything. But if we hover over, you will see that there's messages for other things that are missing. This says it's missing a props type. So because JavaScript isn't statically typed, you just passed in whatever properties you wanted and it came in as an object and people used it and you just hoped you used the right names, right? You hoped it worked. But in Scala, we need to be more specific about types. We need to say what exactly the properties that this test component wants are. Similarly, we need to say exactly what the state is. Now, you can do these with type declarations, but most of the time, if they actually have values in them, you'll do them as case classes. So I'm going to make it so that our props has a message of type string, and we have a state that is going to be some text also of type string. And part of the reason for that will become more clear. Now, this is still unhappy, and if we hover over, you'll see that it needs a thing called initial state. In the original React inside of JavaScript, you would put some code inside of the constructor for your component that set up the initial state. If you forgot to do it, things still ran, okay? Slinky isn't going to let it compile until we tell it what our initial state is. And in this case, I just want some empty text. And now our component is happy and it compiles. And I can add a little bit more to the render method. So for example, I want this message to be my header 1. So that was part of props.message. Okay. For the input, I want this to be a text input. So I need its type to be text. Now, this is unhappy because type is a keyword in Scala. If you have a situation where you need to use a Scala keyword as something else, you put it inside of backticks. And so this will make it happy. You can do this. There's the other place where this is seen is yield. For example, Java has a method on the thread class called yield. And so if you ever decided that you needed to have a thread yield in Scala, you would have to put the yield inside of backticks. Type is a keyword here, and so we have to put it inside of backticks. Also notice that there was this funky colon equals. I'm going to write another one of these things. So we want to specify the value here to be the state's text. This colon equal is part of the Slinky library, and you might ask the question, well, why didn't they just use a regular equal? The regular equal is built into the Scala language as an assignment, and that's not what this is. This actually is producing an attr pair. It's an attribute for our input here. And so they just used a slightly different operator. This is actually, if you ever learned Pascal or any of the Pascal family languages, this would have been assignment in Pascal, so it's not that far off, in order to build these attribute pairs. Single equal will not give you the behavior that you want. The other thing that you might recall from React is if our value for something like the input is being controlled, in this case, it is being built from our state, when the value changes, when people type, we have to actively alter that. So anytime that someone changes this field, I need to set the state, and I want that state to be a copy of the original state with the text equal to the target's value. Okay. Now I could have, in this case, because state, let's blip, blip, blip. I could have actually built this as just a new state of e.target.value, and that would have worked. Okay. Having played with this some though, the problem here is if I add more arguments up into my state, if I make my state larger, this breaks. On the other hand, using a state.copy, it continues to work. Note that setState can also be written to take a function, and that function is the current state. And so if you're going to do copies, you can also shorten this to here. That is a style issue. It's completely up to you. Most of the time when I've done this, I have done the state.copy instead of the underscore.copy. But once again, completely style issue. And this is ever so slightly shorter. Okay, so we saved that. The fast stop should have compiled. It looks like it was happy with it. No, when we come over here, we run it, nothing changed. Why did nothing change? Oh, because this over here is still showing h1 of hello Slinky, and we need this to be our test component with the hello Slinky. Once again, this is type check. This has to match the arguments that are coming into props. If we tried to pass something different here, like 3, this would be a type error because it knows the test component needs a string. Okay, so we are getting the nice static type checking to verify that things are working the way that we want. And now we get the hello Slinky message and stuff to type into is reused. Okay, we're kind of at the end of this video. We've hit the time, so we'll come back and we will fix this bug in the code at the beginning of next video, and then look at how we can get our Slinky stuff working in our full play project.